The probability of event A knowing event B occur, denoted by probability A given B. Now this line here is a vertical line. This is a vertical line. Okay, so that's not a fractional notation. No, that's a given. That's a given. If you remember in intermediate algebra or algebra 2, we learned, actually we have that notation, and on the set builder notation, that's the set of all x where blah 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 blah. If you remember that notation, now this exactly the same notation we use there here. Okay, yeah. So as if it says that probability of A knowing B. Okay, now notation wise, again, this is the probability of the event we want to compute, to consider. This is the one given. Okay, that's the one given. Now, let me continue with the definition. Is the likelihood for event A to happen given event B, continue here, also happen, or already happened. Let's start with an example. I hope using Venn diagram helps our ability to see the situation better. Okay, so suppose I have this let's say this is set A and this is set B. I have 5 here, 7 here, 8 here, 10 here. I believe this is exactly the Venn diagram I used, where the A was math and then the B was English yesterday, or 2 days ago, or maybe both days. But it doesn't matter. Okay, now, and yes, the number of elements in the sample space is 30. So if I ask, for example, what is the probability of selecting A, that will be 7 plus 5 over 30. This is something we learned before. Okay, oh, this is 0.4 in decimal. Now, the thing is, what if then I say probability of A knowing B? In other words, when we compute this probability, we are not selecting from the whole Venn diagram anymore. No, we are not. Selecting from the whole Venn diagram is the first case. The second case, given B, okay, it means we only select from B. Instead of the whole Venn diagram, we only select from B. Okay, so then from there we see, oh, okay, let's see how many elements we select from. Instead of the whole Venn diagram, which consists of 30 elements, we actually select from those elements in B only, which is 5 plus 8, 13. Okay, so knowing B, probability of A given B means probability of selecting A, if we select from people in B. Okay, and notice that this 5 is the one in B, in A also. Okay, probability of A given B, we see how many elements in B first. And of those in B, how many of them also in A? Okay, now the idea of conditional probability for now is that just as simple as that. Okay, in fact, most of the time conditional probability is that simple. Okay, of course it gets complicated later, but when I give you a Venn diagram or contingency table, it's that simple. Okay, now let me ask you to try something that some people think they are the same, but they're actually not, if you have a proper understanding. What is the probability of getting B if we select one person at random, knowing we select from A? Okay, how many elements we select from? 5 plus 7, which is 5 plus 7, which is 12, right? Okay, now of those 12 elements in A, how many of them also in B? 5. Is it okay? Everybody? Okay, nobody say anything, only Lydia, I guess. It gets a lot more complicated later on, so I want you to really get it. I want you to really get it for now, okay? If you don't get it now, very likely you won't get it later, okay? But if you get it now, very likely you have very good chance to get it later. Okay, let's play with the notation. How about probability of getting A given not B? Probability of A given not B. So we select from not A, I'm sorry, from not B. How many elements not in B? That's 10 plus 7, right? Outside of B. Now of those outside of B, how many elements in A? 7. That's right. So we end up with 7 over 70. Now you will see conditional probability will have the following phenomena, that the number you have on the top will be one of the number you have at the bottom. Okay, yeah, the number you have on the top will be one of the number we have at the bottom. Actually, if you think about it, that has been the case since the very beginning, though, because this, for example, in part A here, if you think about this 30 here, this 30, in this 30 you have 7 and 5. This 30 actually coming from, let me erase that. Yeah, this 30 actually coming from 7 plus 5 plus 8 plus 10, right? And you see this 7 and 5 is actually part of the denominator, right? Okay, so let's see, how about probability of not B given not A? Okay, you think about it. So this will be not A. Let me erase that 2 first. Not A refers to, outside of A refers to 10 and 18, that's right. 10 plus 18, that's outside of A. And of those 10, or 10 and 8, and of those 18 elements, the part that is outside of A, outside of B is, so hold on. Not A refers to these two guys, right? Now, of these two guys, which is outside of B? The 10. Yeah, the 10. Okay, the 10. So that would be 10 over 18, which is 5 over 9. Okay, now the answer 10 plus 7 over 10 plus 8 will not be correct because this 7 is not part of the denominator. Right? It won't be. It won't be true. Okay, because for you to select this this element here, okay, it has to start with something on the denominator. Okay, but Thomas, that 7 is outside of B though. It is true, but we select from those outside of A. Okay, we select from those. So keep in mind that this is the condition. This is what you select from. This is what you select from. Okay, now from what you select from 10 and 8, 18 elements. Okay, these 7 elements is not among what you select from. So of course you will not select that because that's not even in your quote unquote domain of selection. Okay. I have to say that if I did say that for now, the conditional probability is supposed to be on the easy side. Okay. But at the same time, you really need to focus. Yeah. At the same time, you really need to focus though. Okay. So you need to know what you're looking for and what you're looking at of the whole distraction. Okay. Now let's make it seems to be more complicated. Okay, but it really question your ability to again focus. Okay, suppose we use the 3-circle Venn diagram. Remember the one we did yesterday? This one here. I think something similar to this, huh? Okay, so select one element at random. Now, the numbers that I put here represent the number of elements in that set. Okay, so 17 is not in A. For example, 17 is not, when I write it this way, it doesn't mean 17 is set A, is in set A. No, I'm saying that there are 17 elements in this set A only. Okay, but I'm not saying that 17 is in that element. Okay, I'm saying, for example, there are 5 people in my household, but none of them name 5. There's no one named 5 Harjuno in my household. Okay, but there are 5 people in my household. Okay, I hope that way I clarified what it means. It's slightly different from how our textbook actually expressed it. Okay, now our textbook actually did something quite common too. So I don't want to say that's wrong. Okay, it's just different way to represent things. Now let's say, for example, from here, find the probability of selecting B given C. Okay, so which is the given? The given is C, right? Okay, so that will be our denominator. You select from C, that will be the total of 2 plus 7 plus 3 plus 15 elements. That's 27, I believe. Okay, now of those in C, of those 27 elements in C, okay, how many elements also in B? The one also in B is, there are 10 of them, 7 plus 3. Is it okay? I know it's more confusing, huh? Yeah, it's more complicated. But you can handle this. I believe you can handle this. Okay, especially with some
Professor.
practice. Yes, huh?
So as long as like the numbers are in the denominator, it should be used for the numerator. So like 7 and 3 were in the denominator.
Yes, that's right. To be more precise, the number of element we add on the top should be part of the number of elements we add on the denominator.
Okay.
Okay. Yeah. So conditional probability means instead of considering it from the whole sample space, the whole Venn diagram, we deal with what we call subsample. Remember the idea of subset we learned in algebra 2? So instead of dealing with the whole set, we deal with the subset. Okay, so not the whole Venn diagram anymore, but only part of that. Okay, now then B given C means you select from C. From those C, what part actually in that B, in B. Okay, that's what it means. Okay. I know that will be a challenge, but trust me, it's doable. Let's see. Next one. What is the probability of getting C given we have A? You try that, and then also probability of not A given C. How about probability of B given not A? Okay, you try this. I give you 3 minutes. No, that's too long. 2 minutes. Okay, let's see how many elements in A. 17 plus 6 plus 7 plus 2. Is it 32? It's 32. And then of those in A, how many elements also in C? That's 2 plus 7. Huh? So there are 9 out of 32. And part C, how many elements? Part C, probability of not A given C. So we start from how many elements in C? So that's 27. Right? Do I make this computation? And then of those elements in C, how many of them not in A? Of those elements in C, these are the one in C, right? How many of them not in A? The one not in A are among these 27 items here. These are not in A. that's 15 plus 3, that's 18. If reduced by 9, that's 2/3. Okay. And then lastly, how about probability of getting a B knowing that person is not in A? So knowing that person is not in A refers to this guy, this guy, this guy, this guy. That's not in A, right? So that's 10 plus 15 plus 3 plus 4. Of those not in A, how many of them also in B? The one in B is only these two, huh? So 3 plus 4. That's 7 over 32. 25%, 32. Now I hope using these two example one, a simple one, and example two, the more complicated one, but I hope still simple. If you can actually figure that out in your mind, then I think we can do problems even if it is in form of conditional probability contingency table. Let's see, suppose we take question number 18 from our textbook. This is question number 18 from our textbook, section 5.4. Okay, let's take a look on that table. And I would like you to, well, in part A, for example, the question is in words, right? What is the probability that a randomly selected adult uses social media given the individual is 18 to 34. So we start from those people who are 18 to 34. Okay, so probability of given 18 to 34. What is the probability that person uses social media? Then how many people actually age between 18 to 34? A total of 150, right? Okay, a total of 150. And then of those who 18 to 34, there are 117 using social media. 117 using social media. Okay, so we start from only those in this 18 to 34 years old age group. Now from that group of 150 people only, 117 of them actually using social media. Okay. Part B. Let me ask you to do it, but I want you to write the notation first and then do the computation. Part B, what is the probability that a randomly selected adult American is 13 to 34 years of age, given the individual uses social media? So given that person uses social media, what is the probability that person is 18 to 34? So the condition is actually this one here. Okay, the condition is social media. There are 338 such people. And of those 338, 117 is 18 to 34. Okay, it's good. Then, part C. Are 18 to 34 year olds more likely to use social media than individuals in general? So to answer that question, we need to compute the following. We already know probability of using social media given 18 to 34. Okay, now compare that with probability in general. So we select from the general population of 530 people. What is the probability from that 530 people? Somebody we can select somebody using social media. Okay, now when we need to answer the question more likely, we basically compare the probability. Okay, so the one we have here, that's basically what we get from part A. That's 117 over 150. Okay, while the one here is social media 338 over 530. Now then we use our calculator to compute it. Once we change them to decimal, it's easier to compare. This is 0.78. This is 0.63774. Okay, then we can see that, yes, that group, that age group, 18 to 34, has more likely, tends to have more, it has more tendency to use social media. Okay, by looking at the probability. So the answer is yes. Okay, and the reason is because then you give this argument, probability of the portion of that age group to use social media is higher than the general, is greater than probability of the general people, the general group using social media. Okay, now actually at this point I want to go back a little bit to the idea of independent. Our textbook talk about independency in 5.3, and they actually gave one rules for two events to be independent. Events A and B are independent. We know the definition yesterday. The definition is that the likelihood for event A to occur is not being influenced by the likelihood of event B to occur. How come we do not use probability of 18 to 34 given social media? Because the earlier question was the likelihood for somebody using social media given that person. So the starting point, if you are 18 to 34, are you more likely to use social media compared to individual in general? So the issue that they want to measure is the likelihood to use social media. Okay, if 18 to 34 compared to if they are in general. Okay, so the starting point, given that that person is 18 to 34, what is the probability that person use social media? Given that person, we don't know the age. If we don't know the age, how much we can say about the chance that person also use social media. So this is the effect we would like, and these are the condition. Okay, these two are the condition. Okay, now let's go back to 5.3. In 5.3, our textbook use a formula that I didn't mention yesterday. And I don't think I need to mention it until now. Of course, we know the definition of event A and B are independent, which means the occurrence of one event does not affect the occurrence of another event. Okay, now, and our textbook gives this formula. If they're independent, if event A independent of event B, then probability of those two events to happen at the same time is equal to probability of event A times probability of event B. Okay, so one way to check if the two events are independent is to check the intersection. Is it equal to probability, the product of the probabilities of each event? Now, okay, that's one way. But another way to check that, is probability of A given B should equal to probability of A. Okay. Basically, we are saying that knowing that B happened, what is the probability of A? Now, probability of, if they are independent, then knowing B given B, the probability of A to happen, knowing B, is equal to the probability of A, even if you don't know anything about B. Okay. Take a look on the illustration I used yesterday. Imagine if I toss a coin twice. Toss a fair coin. A fair coin twice. Actually, it doesn't have to be fair. Okay. Now, the probability that you get a head is, let's say, 0.5 because it's fair. Okay, now what happens if I ask you, what is the probability that the next time you toss it, you get a head, knowing that previously you get a tail? That's still the same, right? Because we know when you toss the same coin the second time, it has nothing to do with the outcome you had prior to that. Okay, as if knowing that the previous outcome is tail doesn't tell you anything about what will happen next. You know, this is the things that I usually say to my wife, like, so, okay, like when let's say I need to go to school, and then I need to go to teach go to West LA College, right? And then my wife say, "Oh, Thomas, it's raining." I will say, "So, does it make me not going to school because it's raining?" I still have to go to school, especially because I teach, right? Okay. I know if you were a student and you, for example, you take bus, right, and the chance that you decide if you go to school or not may change if the rain is actually quite bad, right? Okay, so the reason we get a car, one of the reasons is not only for convenience, but also to reduce our dependency on something else. Okay, yeah, for example. So that's what we mean by independent. Okay, the probability of A to happen knowing B is the same to probability of A to happen, even if we don't know anything about B. Now, okay, if A can behave the same way, regardless he knows something about B or not, then A is independent of B. Okay, and in fact, if A and B are independent, these three statements here are equivalent. So the first statement, the second statement, and the third statement are equivalent. Probability of B given A is equal to probability of B, even if we don't know anything about A. Okay, so going back to this question, part C here, actually I prefer to ask the question, is the fact that somebody is using social media and that person is 18 to 34 years old, are they independent event? Is the event using social media and being 30 to 40 years old independent? Now, to check if they are independent, you can check this thing, okay, which we already had in part A, and probability of using social media regardless the age. If they are the same, then yes, these two events are independent. Okay, now, so in this case, are they independent? Are they independent? No, they are not independent. You're right. Okay, no, they are not independent, because knowing that that person is in that age group, then the chance that person use social media is actually higher. Okay, and not trying to be what you call that, prejudice, or like if you see older people, like let's say my mom, don't go too far. Let's say my mom, and if my mom take classes at West LA College, she will have harder time, not with the school, I believe, but more about how to use Canvas, for example. Okay, yes, she knows how to turn on computer, she knows how to actually browse internet, but to go to Canvas and then log in and then go to Zoom, and at the same time being able to do snipping, copy paste on computer all at the same time. I think that's actually quite heavy. Okay, for her, because well, she's not learning using computer for that long compared to all of us. Okay, so to be honest with you, one of the little reason I asked you give me the estimate of your age, actually to see if there's anybody that may need extra help when it comes to technology. Okay, in the end, I still need you to know all these things. Okay, I still need you to know all these things, because that's what you need when you go to when you transfer to university. That's what everybody expects you to know. Okay, regardless your age group. Okay, and if we see your age group, that's actually discriminatory. Okay, yeah. But then I, as a teacher, not thinking like setting aside that the notion, I see, oh, you know what, if these students needs extra help, I need to be aware with that. Okay, and that's why I asked you, give me the estimate of your age group or of your age. Okay, yeah, make it reasonable. So I usually don't ask question about independence in my test, but I saw this kind of question show up once in the department final. Let me give you the sample problem. Let me give you the sample problem. For example, find x such that uh, math, the probability that the event of somebody taking math and the event somebody's taking English becomes independent. And this is the Venn diagram. Now maybe I use contingency table instead. So taking math, not taking math, taking English, not taking English. Let's say there are 60 here, 40 here, a total of 100. Okay, and then let's say I have let's say I have what is good? 30 here. And what this number supposed to be? What this? Oh, that one has to. Well, that one will be 10. That one is easy. Hold on. What this number supposed to be? Yeah, what this number? I want it to be x. I want this to be x. What this number supposed to be? Such that it becomes independent. If, let's say, this is 30. So we don't, let's say we don't know this, we don't know this, we don't know this, we don't know this. Okay, what will this x supposed to be to make it independent? And we want to see the probability of taking math should be equals to, for them to be independent, should be equals to the probability of taking math given that person take English. Okay, or I think the following is easier. Either you check that one, find out that one, so solve that equation, or you check this, probability of taking English. You need to set it equals to probability of taking English given taking math. X equals to 2, no, it's not. Let's see, what is the probability of somebody taking English? Which one is easier actually? I don't know, I don't know. Probability somebody taking English is, taking English will be x plus 30. X plus 30 over taking English is x plus 30 out of 100. Right? Now that should equals to, given math, there are 40 people taking math, there are 40 people taking math, x of them taking English. Now that's what we need to solve. Okay, that's what we need to solve. So x plus 30 times 40 should equal to 100 times x. You do cross multiply, right? So 40x plus 1200 equals to 100x. 1200 equals to 60x. I subtract by 40x and then divide it by 60. I get x equals to 20. Okay, so for this to be independent, yeah, you miss a zero. You miss a zero. Yeah. So for this to be independent, for this to be for math and English to be independent, then x should be 20. Okay, or more or less will be quite reasonable. Like let's say 21 or 19. I think that's quite reasonable to say that they are close to be independent. Okay. But that's the computation. How do we know that these two events are independent? You look at that. Okay, you look at either this one here or this one, whichever easier to compute given the situation earlier. Okay, how did I get x over 40? Probability of taking English given math. Now, how many people taking math? There are 40 people taking math. Of those 40 people taking math, X number of them taking English. That's how I get that X over 40. Okay. Now that's a little touch base on independence. Now, the general formula, conditional probability formula. From here on, it will be fun. Conditional probability formula. The probability of A given B is equal to probability of B on the denominator. That's for the condition. Okay, and then on the numerator, that's probability of A intersection B. Okay. The explanation has something to do with the procedure that we did our problem earlier. Notice that, let's say this is A and this is B. Probability of A given B, we actually zoom ourselves into the condition first. Right? We zoom ourselves into the condition first. Okay, at that time we use the number of elements in B. We can also now use the probability in B. Now, then what part of that B also in A refers to this part here? Right? Because we select only from B, right? Of those in B, which part in A, right? So it refers to this part here, okay? But that part is actually the intersection. Okay, that part is actually the intersection. Okay. That's how we get that formula. Okay, that's how we get that formula. Now, but notice that we didn't use this formula if we have Venn diagram, if we have contingency table, right? Just like inclusion, exclusion formula, we don't use that if we have Venn diagram or contingency table. We use that if we don't have Venn diagram, we don't have contingency table. Let's say, for example, probability of A equals to 0.7, probability of B is 0.6, probability of D intersection is 0.5. Now, yesterday we have very similar problem. This is yesterday. We have the question is probability of the union, right? Okay, that's something we handled already. But now we can ask further, what is the probability of A given B? Write down the formula first. Okay, and then probability of D given A. Okay, remember, the given is on the denominator. The given is on the denominator. Okay, probability of A given B is probability of D intersection, which is 0.5 over the probability of the condition 0.6. In fraction, that's 5 over 6. Now, what happens if I reverse the given and the condition and the desired event? Then that will be, the denominator will be probability of A, that's the condition, right? And then on the numerator will be probability of the intersection. Okay, keep in mind the condition will be on the denominator. The condition will be on the denominator. Okay, so this will be 0.5 over 0.7. That is 5 over 7. Now that's the simple example. That's the simpler example. Now the following is the harder one. The following is the harder one. But I usually ask this kind of question. For example, let's say probability of A is 0.8. Probability of A given B is 0.6, and probability of B given A is 0.5. And the question is, first one, the hardest one, find the probability of B intersection. Okay, this is considered hard problem because for you to even do the first step, you need to know what to do. Okay, now the key is actually, it has something to do with the formulas for A given B and the formula for B given A. Okay, you write down those two formulas first and see which you can use. Okay, let me ask you to do that together with your break. We come back at 9:11. I don't like the number, but I like the 10 minutes. Okay, let's start again. Let's see, how do we attack this problem here? We need to take a look on the formula. The formula for A given B is probability of B intersection over probability of B. Okay, that's what it is equal to. Now the thing is, this is the one we need to find out. This is the one we have, but we don't have any information here. So we cannot use this formula for now. On the other hand, this formula here, probability of B given A, is equal to probability of D intersection over probability of A. Now, probability of A is known, right? This is the one in question, and this is the one known, right? So then if we know two of them using this equation, we know the other one, the yellow one. Okay, so how do I then attack this problem? Let me write down the formula I will use for probability of B given A equals to probability of D intersection over probability of A. Probability of B given A is 0.5. Probability of A is 0.8. On the numerator is what we are looking for. Therefore, probability of A intersection B is 0.8 times 0.5, which is 0.4. Okay. Now, let's do a follow-up question. Now we get that part A. How about part B? Find the probability of B. Find probability of B. Notice that now we have this guy and this guy from part A. So we can use this formula now to find probability of B. Okay, can you try to work it out? So you write the formula first. Probability of A given B is equal to probability of D intersection, which we already have from part A, over probability of B, which we are looking for. Okay, but we now know this guy and this guy, so we will be able to find probability of B. Okay, try to execute it. There is 0.6 equals to 0.4 over probability of B. So 0.6 times probability of B equals to 0.4. Probability of B therefore is 0.4 over 0.6, which is 0.66667. Okay. Now this problem is not a good problem, but because later on you will see some contradiction. I think later on you will see some contradiction. That's why I will just stop it there. Okay, now, let me ask you to do this one then. Another example, probability of A is, let's say, 0.8. Probability of B is 0.7. And probability of B given A is 0.6. Well, I want it to be higher. 0.9. Will that be cool? No. 0. Yeah, 0.7. Let me make it 0.72. Maybe 0.75. Would that make it? Yeah. So the first question will be find the probability of the intersection. We can do that. Okay, and then second, find the probability of the union. So you will see this question is actually being scaffolded in which for you to do part B, you need to know part A first. Okay, and then if you have a chance, you may want to think about, you may not get it right away, but think about what is the probability of not A and B. That one, think about that first. But the first question should be done in 1 minute. The second question, another 1 minute. I give you extra 1 minute to think about this part C. Okay, try that. So part A, let me separate the work. So for the solution, part A, probability of B given A is probability of D intersection over probability of A. I use that one because we have this number, right? Okay, I have that number here, and I also have this number here. Therefore, I will be able to find these. Okay. So probability of A, maybe I write it another way. Nothing wrong with what I was about to write, but let me write it this way. Probability of A times probability of B given A is equal to probability of A intersection B. We will see this formula again. I am referring to this formula here. We'll see this formula again much later, after test 2, in fact. Okay, but I want you to realize that this formula actually makes sense in the following point of view, that for A and B to happen at the same time, you can see that A happened first and then B happened after A happened. Okay, so even though we want them to happen simultaneously, okay, but this can still be done by seeing A to happen first and then B on the top that A. Okay, as if I'm saying for A and B to happen, I need to have A first happen, and then after that A happen, I need B to happen. Okay, but I need to go through A first. Okay, and I talk too much there. So probability of A times probability of B given A is probability of the intersection. That's 0.8 times 0.75 equals to probability of the intersection. That's 0.6, I believe. Oh. Okay. Now part B, probability of the union. Now then we can use inclusion-exclusion formula because we already have all the ingredients, right? Probability of A plus probability of B minus probability of the intersection. That is 0.8 plus 0.7 minus 0.6. That will be 0.9, right? Okay. Now, how about part C? How about part C? Probability of not A but B. Now, before I answer that question, let's take a look first in Venn diagram what it looks like. What it looks like in Venn diagram. So let's say this is A, this is B. Now, outside of A but inside of B refers to this. Outside of A but inside of B. Outside of A, inside of B refers to that. There are actually two ways to compute this. But I think the easiest one is by first taking the whole B. You take the whole B. You take the whole B, and then you cut this part out. Okay, so probability of not A but B can be seen as the probability of B, but we cut away the intersection. Okay, then probability of B is what? Probability of B is 0.7. Probability of intersection is 0.6, and that's 0.1. Okay, now why I ask you that question? Because I have this in mind. Probability of B given not A. Can you do that? Probability of B given not A. that is equal to, on the denominator is probability of the condition, and on the numerator, probability of the intersection, which we have done earlier. That's 0.1. And how about the probability of not A? That's 1 minus probability of A, right? That's 0.1 over 1 minus 0.8, I think. Yeah, 0. Eventually, you will see that's 0.5. Okay. I think I'm actually done with this section here. Of course, you can do a lot more problem from 5.4, our textbook. And I believe when you say here in our discussion of the day earlier, when you say here, right? I hope you read my notes there. I have suggested homework there, but let me write it down here also. Suggested homework from this 5.4. Will be from number 1 to number, I still remember number 1 to number 43. From number 1 to number 43. Let me ask you if you are done copying this, if you copy this. Okay, here's the thing. I did mention earlier that in my test 1, sometimes I have conditional probability, sometimes I don't. Okay, the underlying concepts always in my test 1. Okay, so remember yesterday we did the choosing. I mean, we did the selection of more than 2. Let's say for example, we have this, our classic example for this class. The math and English. We have 5 here, 7 here, 8 here, 10 here. And then I say, let's say for the question is select 3 students from this group. And let's say the question is find the probability that all 3 take math. Be very careful, don't change that A to E. And the way we did it yesterday was, well, what is the probability the first one take math? That's 12 over 30, right? And then the second one, what is the probability the second one take math? That's 11 over 29. Now notice that this 11 over 29, is not probability of taking math if we select one person. Okay, that's what we have here. If you select only one person, the probability that person take math is 12 out of 30. Okay, but what is this 11 over 29? This 11 over 29 is actually probability that you get a math person given the first person you took was a math. Okay? So in other words, the idea of conditional probability already instilled yesterday. We just didn't describe that in a formal way. Okay, we did it by intuition. Okay, so in your test 1 on Monday, you will have this kind of question. By the way, I'm not done yet with this. The next one is 10 over 28. Okay, and then this 10 over 28 is probability of getting math again after the first two are math. Okay, so that 10 over 28 is actually conditional probability. 11 over 29 also a conditional probability. But yesterday we did it without formally invoking conditional probability concepts. Okay, but the concept's already there. We just never formally bring it up. Okay, now so this question, for this type of question for sure will be in your test 1. Okay, now sometimes in my test 1, I have question like example 1 or example 2. Sometimes. Okay, now or example 3. Basically a basic question about this conditional probability. You need to know how to write the conditional probability and how to compute it. Okay, but I never have question like past this line here. I never have question in my test 1 past this line. Okay, so let's say this is test 1 boundary. Okay, test 1 boundary. If you ask me, Thomas, how far do we go with test 1? We can safely say that we study up to the easy part of 5.4. Okay, but for sure 5.4 will show up in a lot more formal way in your test 2. So in your test 2, anticipate question like this, the one that you use formula. Okay, the one that you use formula for conditional probability, that will be in your test 2. The one without using the formula, but basically we apply that contingency table or Venn diagram may show up in your test 1. I think this is on the easy side, right? Maybe I ask you, I want to be nice on Monday. Okay, I want to be nice on Monday. Do you want conditional probability like example 1, example 2, example 3 to be in your test 1? Maybe let me create a poll. Sorry, give me some time. I had a question. Give me a second. Do you want conditional probability like in our examples 1, 2, 3 be in your test 1 on Monday? Answer 1, yes. Answer 2, no. Okay. Oh, hold on. Okay, I have that poll. Would you mind to tell me your choice? How many students currently there? 17. Okay. Let's see. By the way, do you see the result? By the way, let me share that with you. Can I share it? Can you see that poll? So far, only 12 people making the choice though. Let's wait. Let's wait until 9:50. Okay, so 14 more minutes. I know some people just sign on to Zoom, but they don't pay attention. Okay, it's up to them. Actually, if that's what they want to do, they don't need to be here though. But anyway, so yeah, there are 18 participants, including me. So I have 5 more people need to make selection. Right now, the difference is 2. With these 5 people, there's a chance that it get flipped, right? Okay. Well, anyway, we will wait. Let me go back to our notes.
Professor, real quick.
Mm-hmm.
For the test on Monday, I know you say you wanted to see our face and our hands. I don't know how to do that with the computer. I know how to like get it to my face, but the hands part, I don't know how.
Just move your webcam. Just move your webcam such that it can show your face and your desk at the same time.
Okay.
Okay.
I'll try.
Yeah. Mm-hmm.
Right.
Okay. Let me pull this back. Now, with the time I have left, conditional probability is actually something quite interesting, though. It is actually a method, one way to zoom into the actual situation. Okay, one of the discussion I have with other people, somebody, let me say, somebody that I consider more power. Okay, oh yeah, I have a question too. My printer is too big to fit in my room, so it's stored in my brother's room. Will it be okay for me to leave the room and camera's view for 10 minutes? Or should I ask my brother to scan the test for me? As long as when you do it, it's actually feasible. So, you know, like your brother will print it for you, right? Okay, and then when you start the test, let me stop sharing. So when you start the test, then you show it on your screen that the paper you're using is actually blank, only the blank test, and then you start working on that. Okay, and then you start working on that like that. Okay. I don't want to be too strict in the sense that make you get this distracted from your test though. Okay, I just need some formality. Now, what about scanning it back? Now, after you work it out, I would like you to actually show me again on your screen. Okay, this is what the one I have, you know, okay. You know that I recorded, right? Okay, so when you show it to me like this, oh, you know what, well, Thomas, I know it's not really clear, but you can see approximately what it looks like, for example. Then you ask your brother to scan. Okay, yeah. Let me tell you one thing that may be surprising. This could be surprising. Are you ready, everybody? I want to give you good news. Here's the good news. I will just say it, I will not write it down, okay? Now, for your test, I don't mind you to do open book. And I don't mind you to do open notes. If I were you, I will create some cheat sheet so that I don't open the book. I mean, so far you notice that I don't teach too much from the book, right? So saying open book is actually distracting you. Okay, if I were you, I will work on the old tests, okay, and make it my cheat sheet. The only thing I don't want you to do, and I'm pretty strict on this one, is I don't want you to share work with somebody else. In other words, I don't want you to get help, and I don't want you to help. Okay? I don't want you to collaborate. You're on your own. Is it okay, everybody?
Yes.
Okay. Now I know
Yes.
it sounds good. I know it sounds good. I mean, I myself, if I were the students, I would be happy because then I have one extra option to actually get some informations which I may miss during my study time. However, be very careful with the trap. The trap is that you may get distracted to do the studying during the test, such that you don't have enough time for your test. That's why I am extremely strict that you have to turn it in by 10:15. Okay. The only reason it takes you longer than, like, you cannot submit it by 10:15 is because it takes you too long. You don't study enough. Even after the cheat sheet that I let you use, you still not prepare. You just set yourself up for failure. Okay. And I also know that the tutoring is from West LA College is available, and some students try to ask tutoring. Let me tell you one thing. Okay. Those students who ask tutor, they tend to get strange answer that you yourself know it will be wrong, because they hardly took my class. And for some strange reason, I don't know why. I honestly don't know why. Those tutors in our West LA College, the one took stats class and still able to tutor, I don't want to say too much about them, but one thing I can tell about my students, all those students who took my stats class and passed, they already transferred. So let's talk about some conditional probability here. And you come up with your own conclusion. So somebody who passed Thomas' class, Math 227 from Thomas, okay, they hardly tutor. At West LA College, okay, the probability somebody actually tutor at West LA College, given that person passed Thomas' class, is actually less than the probability somebody tutor at West LA College, given that person passed 227 but not from Thomas. I really want to say that explicitly, but I'm afraid that's kind of I'm afraid that's offensive. But I'm just trying to tell you the truth, right? Okay, because when you pass my class, you must have some quality, and university will take you. And those students who pass 227 not from me, and they tutor, there is a chance that they may pass that 227 but not doing well in their other courses, such that they have time to still tutor at West LA College. Okay, in fact, those students who passed my class, or I actually have, I would like to recommend you one person, one guy who never took my 227, but he actually learned a lot from my class through students. He took my Calculus 3, by the way, okay, and become a tutor, and then he learned on the sideways on his own from students who took my 227. Then he could tutor at West LA College, and now he decides not to tutor at West LA College because he will make a lot more money by tutoring by himself. Okay, so that's another reason why tutor at West LA College, usually they don't know my material. Okay, yeah, because what, you need to have certain quality. Now this guy already graduated from UCLA math major, applied math major. Now let me see, let me share with you his. He did ask me about, Thomas, would you like to share with your students? He usually just posts his flyers at West LA College because he lived nearby UCLA, which is close to West LA College. Okay, but I would like to share with you his contact. Give me a second. And this is someone I'm actually proud to share with you though. Okay, his email, his name is Miguel Martinez. Martinez. And his email is Miguel mrtc15@gmail.com. So if you want tutoring, you can get tutoring from him, but do not ask him question during the test. Okay, I will let him know I will have tests during what time, and I don't want him to do tutoring during that time. Okay, he's on his own. I mean, but he's someone who also appreciates honesty. He knows me well enough. Okay, so if you want to learn from him, go ahead. But during the test, I don't want you to collaborate with anybody. I don't want you to get help from outside. You are on your own. So prepare your own cheat sheet, especially for test one. It's quite procedural, right? It's quite procedural. So I hope you can do very well. Next thing to say is that according to my survey, the result from test 1 and test 2 predict your final average very well. So basically using your test 1 and test 2 only, okay, using test 1 and test 2, the average, whatever you have in your test 1 plus whatever you have in your test 2 divided by 2, okay, can predict what your grade at the end of this summer very, very well. Okay, not exactly like let's say the average you get is, 82, which is a bit higher than a B, then your final average tend to be B or C. Okay, tend to be B or C. Now, but if your average of test 1 and test 2, let's say, is 45, then at the end of the semester, you will almost to the point that I let you cut my finger, that you will get an F. If you get better than F, cut my finger. Hey, I use probability. I teach you probability and I bet on it. Okay, maybe not my finger. My son needs that. Okay, let me say $10. Okay, if your test 1 and test 2 average 45, and at the end of the semester you pass the class, I pay you $10. But I don't think you want to risk that though. Okay, well, so here's the thing why I mentioned test 1 and test 2, because it predicts very well whatever you get in your final average. Of course, your test 3 and test 4 also significant, but usually those students who get average of 82 in test 1, test 2, they will be able to maintain certain level of success in their test 3 and test 4 and also their final, such that in the end, they actually get B or C. Okay, now here's the thing though. Test 1 is the easiest among all four. Test 1 is the easiest. Test 2, for most of them, is actually the hardest. Okay, now what I want to say is this. Try your best in your test 1. Try your best in your test 1. You can score 80 or above. 80 or above. If your test 1 score less than 60, I really want to say drop the class. Okay, because the fact that you get 60, it's simply because you didn't study. It's all procedure. You just need to practice and make sure that you pass enough. Okay? Okay. Even when you get 70 in your first test, you have a very big chance of not making it. But I saw people getting 70 in first test and at the end still pass the class, even though not a lot though. But I hardly have anybody getting 60 in the first test end up passing the class. If you get 50 or below, don't waste your time. Okay, so I'm not telling you to drop the class right now. No, that's not my point. That's not my intention. What I want you to do is study your ass off for your test 1. Just for all my tests, you need to study hard. But when it is the easiest, You study even more, make sure that you have enough saving when it comes to harder tests later on, okay? Do your best. You don't wait until things get harder, then you try to catch up. No, when it is easy, when you think it's easy, make sure it's really in your hand, okay? Because you may say it's easy, but before you materialize that to be your 90 points or your 95 points or your 100 points, it's not yours. Okay, it's still in your dream only. Okay, yeah, we start with a dream, but you need to materialize that though. Okay, we start with a dream. You need to have that dream to push you, to motivate you to do well. But that's not enough. Okay, we need to do more. Okay. Okay. A lot of you know that phrase, I have a dream, from Reverend King. He actually set the foundation for us. We, from our Dr. King. He set the foundation for us. And it takes a lot more people to fulfill that dream. Of course, that dream is not only his dream, okay? But he's the leader. He was our leader to set the foundation of what we need to do, what dream that we need to fulfill. That's why we have a better today, right? Of course, a lot more can be done, okay? One thing you can do, a little thing of doing well in your test one. How about that? Okay? Yeah, how about that? Do well in your test one, please, please. Because test two, in your test two, I will be happy if you get 50. If you can get 50 or better, I'll be happy already. That's how hard is test two. Okay? Now, for you to have average of 82, then your test one has to be very, very high. Okay? Yeah, you don't want to wait until it gets hard and then ask me, Thomas, do you have extra credit? Do you have this? Do you have that? Nah, no, you procrastinate. I set you behind, you know. The idea of no child left behind doesn't apply to West LA College because it's a college. No child here. We are all mature. We are all responsible on your own life, right? Okay, I can direct you, I can advise you, but there's only so much I can do. Okay, be responsible, be mature. Now, oops. What else I want to say in the next 5 minutes? Give me a second, sorry. Somebody sent me a message. Let me see. Oops. Let me see. Hey, why I can't see? Hold on. Why I cannot see your message? Hold on. Why I cannot see your chat? Oh, here. Here it is. What's the result of the vote? Let me see. Let me see. Oh, where can I find it? What's the result of the vote? Okay, I'm laughing because, hey, where's my... Oh, I get confused a little bit, sorry. Where's my... Okay, my panel disappeared from me while I try to share this. Give me a second. Where's my pen? Oh, shoot. Let me end the poll. I wonder if you can see it. Share the result. Can you see that? Oh, no. Okay, yeah, now I see. Now, yeah, it's a tie. It's a tie. Yeah, it's a tie. So out of 18 participants, one is Thomas, 17 of you supposed to vote. Of these 17, only 14 votes, and we get a tie. Okay, so I still don't know. Let me just ask you to study then. Assume that I will put it there. Okay, assume I will put it there. If it is not in test 1, will it be in test 2? It will be in test 2 regardless. Yeah. Conditional probability will be in your test 2 regardless. It's just about do I put the easy one in your test 2 or the hard one? Okay. In your test 1, you may see the easy. You will see the easy version, which may not be easy if you don't study, of course, right? Okay, but if you study just a little bit, some basic understanding, you should be okay. The Venn diagram and the contingency table case. Okay, but conditional probability for sure will be in your test 2. Is it the hard one or the easy one? Depends on do we have the easy one in. It depends on if you have the easy one in your test 1. You know what? Peter, come here. Peter, come here. Come here. Come down here, Peter. Let me show you my son. But I still don't know how to.
Professor, to clarify something, you probably did. I just want to double check. So
Sure,
for
sure.
the cheat, are
For
we
what?
able to the cheat sheet?
Are
we able to use like notes, or is it pure formulas?
Up to you.
Up to you. Okay.
Do you see my son? Come here. Come here. Step here. Stand up so that they can see you. Okay, this is my son. Do you see his face? It's copy paste. Say hi, everybody.
Hi, everybody.
Where's your hand? Yeah. Okay, go play. Oops. Give me a second. I almost typed something wrong. Okay, share screen again. Nah, don't do that to me. I want you to also know one thing. So your test 1 will end at most at here. Okay, that's where your test 1 will end at most. Your test 2 in future will start from 5.4, this conditional probability. So we have some overlap. We may have some overlap, okay? But if the overlap will be the easy one. Now, the way I see, if you ask me, you already took the poll, okay? You already took the poll, and the decision is it's tie right now. So assume that it will be there, okay? But recently, actually, in the last 2 years, I actually don't put this conditional probability, the explicit one, conditional probability in test 1. I didn't put it. Yeah. Okay. The implicit one is always there. Okay. Now, but what I want to say earlier is this. Let me go to the next new slide so that I don't need to erase that later. Okay. The place that I stopped here is conditional probability. The place that I stop here happens to be the place I stopped in the spring right before we go remote learning. Let me say it again. So last semester in spring, I stopped at conditional probability in class, which the week after that, when we meet again 3 weeks later, at that time, because we get spring break, blah blah blah, right? Okay, so the material after this, which is 5.5, equivalent to 5.5. Last semester was actually taught online already on campus. Now, why do I want to share that with you? Because it means you can find my lecture video online on YouTube. Let me share with you. If you go to YouTube, type Thomas Arjuno. Okay, go to playlist. Now then, why I have so many extra? My son actually put it here. You go to Math 227 East LA College Elementary Statistics. Now, their chapter 5, our chapter 5, 5.5 is actually their 4.7, okay? But then, even though the sectioning or the chapter has different numbering, but the ordering is the same. So after your test on Monday, you can actually start watching the lecture video from my last semester. Okay, now my class at East LA College last semester in spring is a 4-hour-long class. Okay, I would like you to watch them such that we actually can cut times that we spend on explaining things with our class. Okay, so basically you study from my lecture video from East LA College, and then during our class, I still will explain doing lecture, okay, but I will not do as long anymore because you have something to watch from already, okay, and hopefully then I can finish the material better. Because if you take a look with at East LA College material, because of the timing at that time, because we lost 1 or 2 weeks, I could not finish the material, okay? And I expect if I go with the same speed right now, in this summer, then I won't be able to even touch base linear regression. While in your department final later on, we will have linear regression. Okay, so help me to help you watch this lecture video, not only the 4.7, which correspond to our 5.5. No, not only that, okay? But basically on Tuesday next week, I will do 5.5. It's based on 4.7. And then on Wednesday, I will do our chapter 6.1, which is their 5.2, so on and so forth. Okay, the numbering for the section is different, but the order are the same. Okay, now that way I hope we can speed up a bit more and at the same time still learn what you need. Okay, not only for your department final. Your department final is something I should pay my attention and your attention also there, but I also need to teach you what you're supposed to get when you go to university level. Okay, I hope that's good enough for today, and good luck with your test on Monday. Please turn in your quiz. Please turn in your quiz a lot earlier. I read on our login earlier that there will be some maintenance happen tomorrow noon at 3 until Sunday evening. Okay. Now, I don't know if there's an alternate way for you to go to campus and then turn in your homework, but assume that it's not doable, then you need to wait until Sunday evening to turn it in. But if I were you, because that's actually the probability material, most of the probability material you will see in my test one, do those first. Okay, do those first before you study for my old test. Okay, now that's for today. See you then other time.
Thank you.
You're
Thank
very
you.
welcome.
Thank you.